$2.
So my favorite thing about JWST is that it was designed with exoplanets in mind. So back when, this is cool. Here's a cool history of science for you. When Hubble was launched in, I think it was 1991,
Okay.
exoplanets did not exist. Meaning, we hadn't discovered them yet. Lots of astronomers expected them to exist. And an exoplanet is a planet orbiting another star. We have 8 planets in our solar system. You go out and you look at stars at night. All of those stars have planets orbiting them. But we hadn't discovered them yet. Now, fast forward to when JWST launches, which is 2021, exoplanet science is now like a department at a university, right? You have, and in Canada specifically, there are some incredibly good exoplanet researchers, and their job is to find exoplanets around other stars, determine what kind of planet they are. Are they like Earth? Are they like Jupiter? You know, what are they like, right? And now, since we have this telescope that was designed in the exoplanet era, it has tools that can be used to study the exoplanets in detail. And one of the more recent ones, so it started collecting telescope data in June-ish, and over the last few months, they've released a couple of spectra of exoplanet atmospheres. So this is what they do. They point the telescope at a star that they know an exoplanet is there. It's already been discovered.
Right.
From our point of view on Earth, and from JWST's point of view, the planet's going around and it passes in front of the star from the telescope's point of view, right? So the planet it's like a little mini eclipse,
Right.
sort of.
Yeah,
the planet is passing in front of the star.
Yeah.
If that planet has an atmosphere, then the light from the star is just right around the edges of the little planet going around. The light from the star is going through the atmosphere. It's transmitting through. And when you put light through a gas, the gas always leaves a fingerprint. What it does is it absorbs little bits of light in specific places. Like if it has hydrogen in its atmosphere, the hydrogen will absorb a little bit of red light.
Right.
And if it has carbon dioxide in its atmosphere, it'll absorb a little bit of other kind of light. So this fingerprint is left behind as the light goes through the atmosphere. So they take the data from JWST and they can look at the spectrum, the rainbow of light, and see what kind of gases are in an atmosphere around a planet, around a star, 50 light years away, 100 light years away, 1,000 light years away. This is... And not only can they do it, it's built to do it for like thousands of exoplanets. So that's just cool on its own. But now think about, before we were able to do this, all we could really say about an exoplanet is like how big it is and how far away it is, maybe a little bit about its mass. But if you can study the atmosphere of a planet,
that has implications.
Then it has implications.
Yeah.
Like imagine you studied our atmosphere and you found oxygen and you found methane, right? And nitrogen, like that. Those are indications of life. If you find the same things around exoplanet atmospheres, like it's gonna change the game. It's gonna completely open up what we think a planet is in the universe.
And our detection of these atmospheres, like, is it fairly accurate? Like
oh yeah, like the data that I've seen, there was one that they pointed out. I forget the name of the planet. And they were like, look, here's a clear indication of carbon dioxide. CO2 right there. Boom. This is, checked by hundreds of scientists. Like this is a legit detection of CO2 in an atmosphere. So it's accurate. It's based on all of understanding. It's good. I mean, you have to couple this with a lot of other things, right? So you can't just you can't just say, oh, CO2, that means life, right? You can't do that. You need a variety of things.
Sure.
To make a big claim, you need big evidence, right?
Yeah.
So, this is one part of looking for life in the universe. But yeah, it's accurate, and I'm really excited to do it. What they've done so far is big planets, like gas giant planets like Jupiter. I'm really excited to see the data come out about terrestrial planets, little tiny rocky planets. What do their atmospheres look like? Because that's way more close to home, right?
Sure.